Students, today we will learn how to read an ammeter and a voltmeter. Now, as we all know that an ammeter is used to measure the current flowing in the circuit, while a voltmeter measures the potential difference applied across the ends of a circuit. An ammeter is connected in series while a voltmeter is connected in parallel. But whenever these instruments are connected in any circuit, how to take the correct reading, that is something that we will be learning today. Now, whenever we are carrying out any measurement, there are certain things that we need to keep in mind. So, prior to discussing actually about an ammeter and a voltmeter, we will understand these terms. Least count, the smallest measurement that can be done using an instrument. This is called least count. Least refers to the smallest value and count refers to measurement. Now, what is the smallest possible measurement whenever we are using any instrument? Like, for example, say you consider a very simple instrument. For measuring length, we use a scale. Now, can anybody tell me what is the smallest possible measurement with a meter scale? That is the value corresponding to the first division. So the first division has a value of 0.1 centimeter, or you can say it is 1 millimeter. So we are not able to measure any length that is having a value less than 1 millimeter if we are using a meter scale. So 1 millimeter or 0.1 centimeter is the least count for a meter scale. Similarly, other instruments have got different values for least counts. Now, it is quite possible that whenever we are making any measurement, there may be some errors in the observed values. Now, these errors may arise if we are not following the procedure for measurement properly, or they may arise if the instrument that we are using for measuring the value of any physical quantity is faulty. This means it has got some defect. Now, one such fault that may exist in any instrument that has got a calibrated scale is zero error. Now, what is zero error? Zero error is a technical term which means how far away from zero is the reading of the instrument when the real value is known to be zero. This means when exactly the pointer should be stationed at zero, it is lying either below it or above it, as you can see in the adjoining picture. In the first case, the pointer is above the zero mark, while in the second case, the pointer is slightly below the zero mark. These two positions correspond to a situation when no measurement is being done. So in this case, the pointer should be exactly at the zero mark, but instead it is either lying above or lying below. So this is what is actually referred to as zero error. Zero error may be either positive or negative. When the pointer is lying above the zero mark, the error is said to be positive. Now this error needs to be subtracted from the measured value. Similarly, when the pointer is below the zero mark, the error is said to be negative, and this value of negative zero error needs to be added to the measured value. Now this has to be done if we are not making any adjustment in order to remove the zero error. Say for example, you have a voltmeter with a zero error. As you can see that The pointer is not on the 0 mark, instead it is lying below. Now may I ask one question at this point? What type of 0 error does the instrument have? Obviously it is negative, since the pointer is lying below the 0 mark. Now the question arises, if you are provided this voltmeter and you are asked to measure the potential difference, so what exactly you can do in order to get rid of this 0 error? You can see the arrow is pointing towards a knob. There is a adjustment screw to which this pointer is fixed. Now using a screwdriver we can adjust the pointer. We can bring it to its proper position. This means we can bring the pointer to a position where exactly it can point to 0. In this manner also we can remove the 0 error. So least count and 0 error are the two things that we need to be sure of whenever we begin the measurement part using any instrument. Now while measurement using an ammeter, let's first of all find out how to read an ammeter. So firstly, you can see in this ammeter the scale, it is marked in ampere and it can measure values from 0 to 1 ampere. This means 1 ampere is the maximum value that could be measured for current using this ammeter. So you can say that 0 is the lower limit while 1 is the upper limit. So from lower limit to upper limit is what we call the range. So range for this ammeter is 0 to 1 ampere. Now let us count the number of deviations between 0 to 1 ampere. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So total number of divisions, if we denote it with the alphabet N, it is 25. So this means that by proceeding through 25 divisions we can get to 1 ampere. Now if 25 divisions is equal to 1 ampere, then 1 division should be equal to 1 ampere divided by 25. So that will give you 0.04 ampere. So this means least count of this ammeter is 0.04 ampere. This is the smallest possible measurement using this ammeter. So let's use this knowledge in reading this ammeter. Now in this case I am making use of a milliammeter. You can see the scale has been marked in milliampere. Now 1 milliampere is actually equal to 10 to the power minus 3 ampere. Now proceeding in a similar manner, we can see that the lower limit is 0 and the upper limit is 100. This means we can measure values of current from 0 to 100 milliampere. So range of this ammeter, this milliammeter, is 0 to 100 milliampere. Let us count the total number of divisions. Total number of divisions in this case is 50. By moving through 50 divisions, we can go up to 100 milliampere. So obviously in this case the least count should be equal to how much? 100 milliampere divided by 50. So that will give you 2 milliampere. This is the least count of this millimeter. Now, can you find out where the pointer is stationed at this point of time? At which division? Let us count. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So right now the pointer is stationed at the 34th division, isn't it? So if the pointer is at 34th division, one division is equal to how much? Just now we have calculated, it is equal to 2 milliampere. Therefore 34 divisions will be equal to 34 multiplied by 2 milliampere, that is equal to 68 milliampere. So this is the reading shown by this ammeter, 68 milliampere. So in this manner we can do the measurement using an ammeter. Now in a similar manner we can use a voltmeter, which is used to measure potential difference. So this voltmeter can measure values up to 5 volt. So range of this voltmeter is 0 to 5 volt. Number of divisions, total number of divisions, they can count it. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So by moving through 25 divisions, we can go to 5 volt. 0 is the lower limit and 5 volt is the upper limit. So again 25 divisions is equal to 5 volt. Therefore 1 division is equal to 5 volt divided by 25. You can cancel. That gives you 1 by 5 volt, that is equal to 0.2 volt, which is the least count of this voltmeter. So this means every single division of this voltmeter is equal to 0.2 volt. Let's now find out the reading shown by this voltmeter. What is the range? Range is 0 to 3 volt. Total number of divisions in this case 30. See, you can count. There are total 30 divisions. So now you can understand what is the least count. Least count will be 3 volt divided by 30. So this should be equal to 0.1 volt, isn't it? So now we will be finding out the reading of the voltmeter. Very quickly see where the pointer is stationed. Where is this pointing? It is stationed right now at the 21st division, isn't it? It is the 21st first division. 10 divisions plus 10 divisions 20, then the first one, so 21st division. So obviously if one division is equal to how much, 0.1 volt, then 21 divisions will be equal to 2.1 volt. So this is the reading shown by the voltmeter. Isn't it? So in this manner we can use a voltmeter and an ammeter. First of all, we need to find out if there is any zero error, so accordingly we have to do the adjustments either during the calculations or by adjusting the calibration part using that screw. And next we have to understand what is the least count, find out the number of divisions at which the pointer is stationed, and then multiplying the number of division with the least count will give us the value of the measurement. Whether using an ammeter we will be measuring the current, or if we are using a voltmeter we will be measuring the potential difference. Thank you.